In this video, we're going to talk about Activity 3 of the Fundamentals of Calorimetry Lab. We'll talk a little bit about inquiry-based learning, creating a graph, and, believe it or not, dimensional analysis. There's Activity 3. What it has you do is, based on your previous experiments, they want you to build a hot pack and a cold pack. Well, not actually build it, but tell us how much of each chemical is needed to build a hot pack or a cold pack. So these specifications include the mass of water, the initial and final temperatures, but that's it. There's no procedure. This is different than what we've done before. What's going on here? What you are seeing is an example of inquiry-based learning. You may have seen this, you may have done it. Inquiry-based learning is a teaching technique that you either have done or as a teacher you probably will do. It's high stakes but high reward. So rather than being given a specific procedure, being spoon-fed the concepts, we put students in situations where they discover the concepts on their own. So if they learn a concept this way, there's all kinds of studies that suggest that their long-term retention of the concepts they learn themselves significantly increases. Now the downside is, if the students don't get the concept this way, they are confused. So we do this, number one, to help you learn, but number two, so you can see inquiry-based learning in action. And what if you don't get it? That's always a possibility. Like we said, high stakes, high reward. But if you don't get it, there are resources, specifically us. We can help you if you're not getting this activity. The most important aspect is the process. We want you to experience the process of inquiry-based learning. So when you become an instructor, you can be a better IBL instructor for your students to help them learn the best possible way they can. So all we want you to do, give it a chance. If you get the concept this way, you will retain it. If your students get concepts learned by IBL, they will retain those concepts. Okay, now let's talk about the activity specifically. One of the things you do is create a graph of your calcium chloride and ammonium chloride. Plot the mass on the x-axis, change in temperature on the y. The slope is the change in temperature per gram of salt dissolved. These graphs will help you in designing your hot pack and cold pack. If you're familiar with Excel or another graphing program, you already know how to plot, make a graph, find the slope. That's all great. However, if you haven't used these programs, you may be thinking something like this.
No! No!
Those are good solutions down there, but they won't help you with the graph. What we will do is we'll show you how to use a graph and find this, make a graph and find the slope. If you already know how to do it, use the slider, skip through this section. So open an Excel sheet, put the headings of mass and temperature change, type in your data from your data table 1. Just a note, this is not actual data. Click on the Insert tab of the spreadsheet, highlight your data, click on the scatter chart. There's a bunch of charts on Excel. Some of them will even work for this. I like the scatter chart. I also like to do the scatter chart with no lines because we're going to be adding a trend line to find the slope. So here's our chart so far. We've got dots, we've got our data. Now we're going to add a trend line. And Excel will do this for us. So you want to right click with your mouse on one of the data points. You will see a menu. On that menu, you want to click on Add Trend Line. Another menu pops up. Be sure that the display equation on the chart is selected. You can also select the R squared value. That tells you how close your data is to a straight line. An r-squared value of 1 means it's close to a straight line. If the value is less than 1, well, your data is a little bit wonky, but we'll still use it. Here's our graph now. The slope, the value in front of the x, is what you need for your cold pack calculations. We'll take that to our next slide. So what does this number mean? Well, the number has units. The y-axis of the graph is degrees C. The x-axis is grams. That means our slope is negative 0.4021 degrees C per gram of the added salt. The negative sign tells us that the temperature drops. So this substance is what we want to use for our cold pack. Dimensional analysis will now allow us to find the amount of solute we need to drop the temperature from 25 degrees to 3 degrees. Now, the hot and cold packs are both 100 grams. The amount of water that we used to gather our data was 100 grams. This slope will work, no further corrections. The slope is negative 0.4021 degrees C per gram. Our target unit is grams, so we need to set up our units so that degrees C cancel and we are left with grams. There's our slope. That's what we need. We can't use the slope as written. We have to invert it because our target unit is grams. If we multiply that times negative 22 degrees C, that's our temperature change. Numbers on the top get multiplied, numbers on the bottom get divided. Degrees C cancel, and we have 54.7 grams of salt in our cold pack. We did it. Great job. You can do this calculation with your data. And of course, if you have questions, contact your course mentors. Here is our information.